Okay, so for 6-2 parallelograms, these are types of polygons. And first off, we got to get some vocabulary out of the way. Quadrilaterals, okay, those are four-sided figures. Their angles add up to 360. Remember, the key ones that I told you guys to memorize are triangles equal 180, four-sided figures, aka quadrilaterals, equal 360, five-sided figures equal 540, and six-sided figures equal 720. This is just really handy information to memorize. Anything past that, you should just use the formula n minus 2 times 180. But memorizing these four will save you a lot of trouble from having to do the formula every single time, because we use these quite often. So keep that in mind. Maybe if we put 6, 5, 4, 3 in there. So now let's talk about quadrilaterals. This 4 section, okay? We got to get some vocabulary words out of the way. First up is consecutive versus opposite. So these are two very different words. We know opposite means across from, but consecutive meaning they're next to each other, but not the same as adjacent. So adjacent was when we had angles that were right next to each other, okay? So angle 1 and angle 2 right here, they're adjacent because they share a vertex, okay? That's what these two here have. And they're also supplementary because that's a straight line, but those two are adjacent. Consecutive is a little bit different. Let's say, and I'm just going to draw a quadrilateral here. These angles right here, I'm going to call them 3 and 4. 4 and 3. Those two are consecutive, okay? Do you see how that's different from 1 and 2? So that's something to think about. Consecutive, they're next to each other, but not right next to each other like adjacent angles are, okay? So keep that in mind. Remember, adjacent angles could also, they don't have to be on a straight line, okay? Those are also adjacent angles, 1 and 2. 3 and 4 are consecutive, okay? And then opposite, they do not share a side or angle, and they're across from each other. So 4 would be opposite of this 4. 3 would be opposite of this, okay? And then opposite sides. So this side is opposite this side, and then this side is opposite this side. Well, consecutive sides would look a little bit different, okay? These two sides are consecutive. They're next to each other, okay? So that's just something to keep in mind when we get to this parallelogram facts down here. So our parallelogram facts, they're very important to know, and they each have their abbreviation because it's a lot to write out to say both pairs of sides are parallel, where we can just use this abbreviation. So the part about parallelograms, the most important part, is where it gets its name. Both pairs of opposite sides are parallel. So if we have a shape, we have opposite sides are parallel. So these are parallel, and these are parallel. Now, remember everything we learned about parallel lines cut by transversal, right? We learned that parallel lines cut by a transversal, we're going to pretend that we can see that out right there. I'm even going to erase the second half of this. That way we can see it a little bit better. So, parallel lines cut by transversal, remember the things we know about parallel lines. Alternate interior angles, they're congruent. Alternate exterior angles, those are congruent. Same side interior angles, like 1 and 2 right here, those are supplementary. Same side interior angles equal 180. So remember that from chapter 3. Remember, all of geometry builds on itself, okay? So we have opposite sides parallel, so it works the other way too. These two angles would be same side interior angles, which actually brings us to, that we'll talk about that more on this green one. But our next one is that opposite sides are congruent. So this is parallelogram, opposite sides congruent. If we're typing this out and we don't have symbols that we can use, we can just say, for the first one, we can just say opposite sides parallel. For the second one, we can just say opposite sides congruent. Or you can use the equal sign with a squiggle. That's if we don't have the symbol editor, okay? So that's handy to write out. So opposite sides are congruent. So just opposite sides equal. Remember, sides and angles live in different worlds. Angles have degrees. Sides usually have measurements like inches or feet. Do not confuse the two, okay? So that's about sides, parallel and congruent. Opposite sides are both parallel and congruent. Now let's talk about angles, because angles are super duper important. And there's two things about angles. First of all, consecutive angles are supplementary. So that's what I said about same side interior angles. Consecutive angles, like A and B right here, angles that are next to each other, like what we talked about up here, are supplementary, which means they equal 180. Which means if this angle was 80 degrees, the consecutive angle must be 100 degrees. Now, if this angle is 100 degrees, the consecutive angle, the angle that shares a side with it, must be 80 degrees. Same thing over here. This angle is 80 degrees. The side that shares a wall with it is 100 degrees. Which actually brings us to our next one. Opposite angles are congruent. These angles that are across from each other, the 100 and the 80, those are congruent when they're across from each other. And that's all has to do with the parallel lines portion of this, okay? So that's how the first four parallelogram facts work, and we can abbreviate these two to just consecutive angle supplementary and opposite angles congruent. Or you can use the equal squiggle. You can just use the ones that are there. Doesn't matter. And our last one, diagonals bisect each other. So think about what bisect means. It means to cut in half. So if I have a parallelogram, the diagonals go from corner to corner, okay, across the shape. So what it means to bisect each other is to cut in half into two equal parts, right? So if I cut this in half, those two parts are equal. So if this is 2, this is 2, this whole thing's 4. Same thing over here. If this is 5, this is 5, this whole thing's 10. So that's very important about the diagonals. The symbol we use for parallelograms, it's what we've been using this whole time, is just the little parallelogram, okay? And then it has 4 letters, so A, B, C, D. If it ever doesn't give you a picture and it asks you to draw this parallelogram, when you draw it, just draw a parallelogram, and don't go A, B, C, D. Go all the way around. A, B, C, D. Each letter should connect. See, if I went from B to C right here, B and C wouldn't touch, but B and C should be touching. See? So keep that in mind. I'm going to talk about some example problems real quick. So this first one, let's zoom in a little bit. This first one, as we can see, it's asking, what is the measure of angle P? Well, it says it's a parallelogram, so that's a key part right here. So we know, let's think about, are we working with angles or sides? Well, angle. What do we know about angles? Consecutive angles are supplementary, opposite angles are congruent. So now I just got to know, is it opposite or consecutive? Well, to the angle we know S is 64. Well, P, it's not opposite of it, Q is opposite of it. P is consecutive, which means it must be supplementary. Consecutive angles of a parallelogram are supplementary. So we do 180 minus 64 to find that angle. The next problem that I want us to look at is having diagonals bisect each other, okay? So this problem you may see on Math Excel. This is just involving some algebra skills as well, okay? Don't forget, if they bisect each other, they cut each other in half. So I can set up two equations. X is going to equal y plus 2. And you're like, but wait, I can't solve that equation because it has x and y's. Well, let's make our second equation. Y plus 10 equals 2x minus 8. Well, if you remember from Algebra 1, the substitution method, if I know x equals y plus 2, I can replace x with y plus 2. So I'm going to rewrite this, but instead of writing x, I'm going to put in parentheses y plus 2 minus 8. And then I can distribute y plus 10 equals 2y plus 4 minus 8. Now we're just going to combine like terms. So I'm going to move this y over, and I'm going to combine those two. Okay, so now I have y. That's going to be negative 4. I'm going to add that 4 to get y equals 14. Now I could plug that back in to this other equation, If I know y equals 14, y plus 2 is going to equal x. So x is going to equal 14 plus 2, which is going to equal 16. Okay, so that's just a little refresher about how to do substitution in equations. And it goes through it, it walks it through more step by step in each problem. And actually, this question is asking for what Km is. So I'd have to plug in x and y and add those together, which you can see they did here. And I highly recommend looking deeper at this example problem. They walk through it step by step on Realize. If you look at example problem 3 on Realize, it'll be there for you. The other thing, the other type of problem is really simple, okay? All this is, and we didn't even put this in the notes because it's this simple. It's saying if we have a bunch of parallel lines and at least one of these sets is congruent, then they're going to be congruent. So we know AB, BC, CD, they each equal 2. So that means these ones are all going to be congruent too. EF, FG, GH. So if EF is 2.25, EH is going to be 2.25 plus 2.25 plus 2.25, 6.75. And that's literally, if you're doing the problems in the textbook, that's literally all you're doing right here. So it says PQ, they're equal. So I can say ZU, so from Z to U, well, from Z to X and X to T, well, X to T is 3, so X to Z is 3, so Z to U is 3. So we just say ZU equals 3. It is that easy. Just look at the numbers that are already on the picture. Make sure you're going along the same line. But that is what 6-2 parallelograms is all about.